Before we talk about the exterior angles, the exterior angle theorem, let's talk and just remind ourselves about interior and exterior angles. So interior are angles that are on the inside. And when we talk about polygons, they're going to be those ones that are inside the closed figure. So we have angle 1, angle 2, and angle 3. And we know that at least for a triangle, that if they are interior angles of a triangle, they're going to add up to be 180 degrees. Exterior angles. An exterior angle is created when a side length is, so if this is the side of the triangle, it's extended past the vertex. And the exterior angle is created. So another one here would be 9 would be the exterior angle. This angle right here is not exterior, but it is a vertical angle to angle 3. So the exterior angles are created when a side length is extended. Here's another one. So 7 would be the exterior angle. 6 would be the exterior angle. 4 and 5 would also be exterior angles. The exterior angle theorem says that if you have an exterior, so the exterior angle is angle 4. So angle 4 is our exterior angle. And that angle is created when this side length Rn is extended out. The theorem says that angle 4, which is the exterior angle, is equal to the sum of the two remote interior angles. And we say remote. Remote means far away. So since 3 is adjacent to 4, that's not remote because it's touching it. So we want the angles that are far away. So we look at angle 1 and angle 2. Angle 1 and angle 2 are the remote interior angles. So exterior angle theorem says angle 4 is equal to the sum of angle 1 plus angle 2. Angle 4 being the exterior angle and angle 1 and 2 being the remote interior angles. The exterior angle is equal to the sum of the two remote interior angles. So here we want to find the measure of angle 1. That is the exterior angle. It is created when side length YZ is extended. So it's this angle right here. So we know from the theorem that the exterior angle will be equal to the sum, so that's addition, of the remote interior angles. Now angle 1 is equal to 65 plus 50. So here is the exterior angle, and here are the remote interior angles. So the sum of angle 1, or the measure of angle 1, will be 115 degrees. Again, angle 1 is the name of an angle, not the measure of an angle. So here's a little bit more complicated of a figure. We are going to find the measure of each missing value. So first we can find angle 1. So angle 1 is interior to this triangle VUT. So angle 1 plus 35 plus 36 is equal to 180 degrees. Angle 1 is a name, not a measure. And this is the triangle angle sum theorem. So we're going to give a reason for each value that we find. So we can solve for angle 1, and we get of 109. So that's the measure of angle 1. So now angle 1 is actually an exterior angle to URV. So this blue. So if we extend the side RV, U is an exterior angle to that triangle. So we can use the exterior angle theorem. And we know that the measure of angle 1, which is the exterior angle, is equal to the sum of the two remote interior angles. So that's angle 2 plus 80. Again, 1 and 2 are not measures, they are names. We have a measure for angle 1, so we can plug that in. That's 109. And then we can use that to solve for angle 2. So just subtract 80 from both sides, and what we get for a measure of angle 2 is 29. And we should be boxing our answers. We should have boxed this answer too. So we're giving a reasoning to find each angle measure, a reason to find the angle measure, and showing work in between. Now we have to find angle 3. Angle 3 is an interior angle to VST, this green triangle. But if we think back to chapter 1, this line right here is a straight angle. And angle 1 and angle 3 are adjacent angles that add up to be that straight angle. So we can remember that angle 1 and angle 3 are a linear pair. We can't forget about those angle pairs that we've already learned from past chapters. So they're a linear pair. So angle 1 plus angle 3 is equal to 180. We know the measure of angle 1, that's 109, plus angle 3, kind of looks like a 4, is equal to 180. So we can subtract 109 from both sides, and we get an angle measure of 71 degrees. So making sure that you give a reason, you show your work, and then the final answer. And then sometimes we have to work with algebraic expressions. So we can see here in this picture that angle O and angle W are the remote interior angles. They are non-adjacent to this exterior angle that is created when the side length is extended past the vertex L. So this is the exterior angle. We know that the exterior angle is equal to the sum of the remote interior angles, because it's the exterior angle theorem. So the exterior angle is 2x, oops, it's not a 2, that's a 12. 2x minus 48 is equal to the remote angles, so that's going to be the value of x and the measure 32. And now we just have to solve this equation for x. So we can subtract x from both sides. Then we can add 48 to both sides. So now we're just algebra 1, actually pre-algebra solving for x. And x is going to be equal to 80. And that is a degree measure because it is right here. And we could check ourselves too by plugging it back in to this angle. And actually we have to plug it back in. We need to find the measure of FLW. So FLW is this angle right here. So angle FLW is the 2x minus 48. So we can say 2 times 80 minus 48 And you should be doing your calculations on the calculator at this time to make sure that you're getting the same answer as we are. So 2 times 80 minus 48 is 112. And that is the measure of FLW. So we could check ourselves. Is the measure of X, which is 80, and the measure 32 equal to 112? So on your calculator, 80 plus 32 is 112, and we know that we are correct by checking our answers.